So the Zen of Python, I would call the Zen of Programming, because these are succinct stanzas that apply to all programming languages, really. And there's nothing here that is specific about Python, and because it's very high level, I don't think that there's anything here that that can't be understood by all programmers. Because the Go proverbs, as you'll see, the language is more towards a systems programmer. But whether you're a web developer or systems programmer, I think you can get this. So beautiful is better than ugly. I think that this is, it's subjective, but it's also something, the old quote, I know it when I see it. You can look at code and you can say this has sort of an aesthetic style to it. And that style is generally, Dave Cheney gives a really good example where he draws a line through the center, well not the center, through a margin of the code. But basically, if you notice that most of your code aligns with a single bar and there's a couple of jutty arrows, that's probably beautiful code. If you notice that your code is jutting like this as you go down the page, it's deep into from the left side to the right side, it's going deep to the right side and it's zigzagging, that's ugly code. It's not going to look very pretty. When you just look at it as a shape, it's jarring, but also it indicates that you have a high cyclomatic complexity because you have lots of nested statements. There might be nested ifs, might be nested tries, might be nested switches. If the code never reaches the white space point back towards the margin inside of a single screen, then you have a candidate for code that probably needs to be pulled out into multiple functions, because you should be able to see this dome shape of the code over and over again as you scroll the file. You shouldn't be seeing the jagged, jutty thing. So I think that that's what beautiful is better than ugly means, is just that the code should have a certain flow to it, that the aesthetic is recognizable to most people's eyes. Explicit is better than implicit. This goes to what I was talking about with ES modules, where, and Go follows this perfectly, if there's a package name and the package name is appropriately named, and then I have a dot and I have a function or a constructor or whatever off of that package name, then it is clear to the reader where the package came from, what the package intention is, and what context applies specifically to the function that comes from that package. And so, and in general, it really stinks when you have to go hunt through documentation or source code to figure out how something works. It's nice when things are explicit, because then in the examples it will show, and I get some of the argument for certainly reasonable defaults, but I also really appreciate it when, in an example, all of the 10 options that can be specified are there in the example. And they're just set to their default values in the example. So if I copy and paste the code, it would be the same as passing an empty config object, but at least everything is explicit and I know exactly what options are available to me and I know what the defaults are intended to be. And there's lots of other cases like that where less global scope, more package scope, less. There are cases where we need one-letter variable names because of its common convention. It makes things easier to read. For example, I is a counter. This makes sense, but in general, we shouldn't be trying to staunch out all the vowels. We want things to be explicit, to be readable, and we'll get to that more. Simple is better than complex. So obviously, if you can look at it and you can understand it at a glance, you don't have to sit there and think and be like, okay, let me break this down. You know that you're violating these first 3 rules, which I dub P1 through P19 is what I dub these when I I'm starting to do code reviews where I use G1 through G19 and P1 through P19 to say this is why I think this is good or this is why I think this needs improvement, because then it's not just, me being an old fart with, it's like lots of old farts have said this, so I feel a little bit better about it. But if you have to restructure code in order to understand what it does, it's probably not beautiful. It may not be explicit. You might have really short variable names that aren't clear. TMP is sometimes better than T. That's letting us know that we don't have much time left before the building shuts down for the night and the lights will go off and we won't be able to turn them back on. Yeah, and it's not simple. Now, complex is better than complicated is one that is a little bit difficult to understand, but I would phrase it like this. We need complexity sometimes because an algorithm may be complex. But we don't need complicated, and I think everybody, maybe not you two, because you're yet young, maybe not quite into your programming careers, but everybody's had the situation where you go to refactor some code, you would try to follow the don't repeat yourself principle, and you end up with a function that's a little bit wonky. It has maybe too many options in it, or the options that it has don't quite make sense. And you kind of get lost at it. So you got all the abstraction quote correct, but then the abstraction makes the code complicated in terms of understanding it. That is a good indication, as we'll talk about later, that you probably need 2 functions there, or maybe 3 functions. And the functions might have 5 lines of the same code, but it's complicated if you try to make the abstraction work for all 3 things when they're similar things, but they're just different. The way that you calculate the area of a circle is not the way that you calculate the area of a triangle or a polygon. And so if you have functions for calculating the area of something, you could try to smash everything into a calculate the area function, but that would become complicated. Even though many of the principles would be the same, it would make more sense to have different functions for shapes that have different rules. As a, off the top of my head example. Flat is better than nested. This one is really simple. The more that you have to go into an object, in the Java world, you've experienced this, where you have a something.config, .get instance of inner private object, .config, .get instance of other inner private object, .get config. This is complex. If you have nested state, particularly you'll notice this when you go to test your program. If you have to set up 11 million things in order to test the functionality of an object or a class or a package, you have probably nested things too much. You have too much state too deep. And there is an elegance to it as you start to do it, but you will probably find that if you denest it and put things at the same level and just have them use each other rather than be nested inside of each other. And I wish I could bring up a code example of that or give an illustrative example off the top of my head. But is there any ambiguity about what I'm talking about there? Do you have a case in mind of your head of, yeah, I know where I've run into this before. I'm getting head nods. Okay. So sparse is better than dense. There's unlimited white space. Dave Cheney said, just like code should read like a paper. You have paragraphs, and between each paragraph you put a break. So between your functions, you have breaks obviously, but within your functions, you have a grouping of code that does the calculation of the area, boom, that's one thing. You do you've got the couple of lines of code that have the calculation of the change in position, that's one thing. So you have paragraphs within your code that are a couple of lines long, maybe 3, 4, maybe just 2, probably more than 1. But yeah, we don't want to optimize for what's really hip in JavaScript right now is doing all these arrow functions where you do 10 things in a row. This is bad. This is objective. Well, according to just about every software engineer in existence, it is objectively bad to put, and it is because it's not readable. If you ask, somebody might say, oh no, I prefer it this way, it's easier. No, if you actually ask them to read it, you will see that they take more time to read. It is easier to read from top to bottom than it is to read from left to right, and certainly not from right to top. And right to top is the case when you use async await incorrectly in JavaScript. You have all these try catches, and then they're nested, and then you have to be reading right to top to figure out what's going on so that you can go back down. So, and that leads us to number 7, which is readability counts. It's all about readability. And almost every software engineer that I hear speak at conferences has a strong focus on readability. You don't want to optimize for keystrokes. You don't want to optimize for fitting things in a single line. By the way, I didn't finish that, but map, filter, reduce, map, people do that in JavaScript. You see that and they use the little arrow functions. So it's just an arrow and then a value, and then a dot, and then another. Don't do that. Readability counts. Special cases aren't special enough to break the rules. So again, will somebody go hit that thing by the TV over here?
840.
Yeah, so if you hit that should give us a little bit more time. Okay. Or, wait, oh, it came back on. Special cases aren't special enough to break the rules. This is, Crockford says this really well, although he's really abrasive, as am I. But if something is useful, something being useful is not a good enough reason to use it. If there's two ways of doing something and one of them is useful, but the other one is guaranteed to work, use the one that is guaranteed to work every time, because you can always find a use for a thing. He said it extremely well in his JavaScript the Better Parts talks. We're humans. Our separation from the animal kingdom is how wonderful we are at finding uses for things, even useless things. And he gave some sort of example of basically Rube Goldberg machine type example. We will find uses to take something that was not intended for a purpose, and we find a purpose for it. So anything can be useful, and this is dangerous. Although practicality beats purity. So not Dave Cheney, I don't remember his name. Well, it's not that I don't remember his name. I don't remember his name off the top of my head. I think I do. Anyway, he gave a talk also that was on Go. It's called The Things in Go I Never Use. That is also in the link of the Creeds of Craftsmanship that are down in the doobly-doo, as well as in all of the chats for this thing. At least it should be. Let me go make sure that it made it into the other chats for this thing. Oh, whoops, this is going way too wide. Oh yeah, it's in all the chats for this thing because I posted it in Discord and then that posted everywhere else by virtue of Restream. So what was I saying? Although practicality beats purity. Oh, so he says one thing he never uses is else, which, by the way, I would challenge you this. If you use else and you don't think that there's anything wrong with else, then you need to go a week without using else because you are writing really nasty code. Else is something that should only be used in exceptional cases, and that would be a case where practicality beats purity. Else is a tool to be used with extreme prejudice. There are cases where it doesn't make sense for a single line that needs to be there to not break the flow of the code, to then go put in an extra function or to break everything else that would come after the else into its own function and then call two functions. There are cases where, with extreme prejudice, it is acceptable to use an else. But generally speaking, if you're using an else, you're not thinking like a programmer. Because here's what your if statement looks like. It looks like if normal case that's going to happen 99% of the time, these 20 lines of code. Else, do nothing. And now you've indented all of your code and started one of those jaggletooths that you didn't need to start. So, but, you do need it occasionally. Errors should never pass silently. This is one of the reasons for use strict in JavaScript. This is just good practice. This is very strong in the Go community. As I said, Go is the spiritual successor to Python. It follows all of these rules. All of the Go, the core Go team, the people that speak at the conferences that are the big Go heads, they all say these things either in their own words or even quote them occasionally. But errors should never pass silently. If there's an error, we want to know about it. If nothing else, we need to log it out as a warning, but there probably should be some sort of event stream. Say that you have something where you can do a callback and collect those errors somehow. You don't want errors. There are certain errors. Your database returns 404. You want to check the error. Okay, this is the next part, unless explicitly silenced. So a lot of database libraries, if nothing is found, they throw an exception. If there's a SQL error, they throw an exception. So what you want to do is you want to catch that error. You want to check to see, is error type not found? If the error type's not found, return null. You're fine. Because your program knows to handle, you were looking for a query of, is there anything in the set? 0 is an acceptable number of items to have in a set. If you know that's the case, return the empty array or return the null value and then go create the user or go create the bookmark, right? But you check that error and you make sure that it's the not found error and that it's not the connect to database error or the invalid database or invalid SQL syntax error, because you go change your SQL here doc string and you forget a comma and your error is swallowed, you hate yourself when you finally find it 4 hours later. In the face of ambiguity, refuse the temptation to guess. P12 is probably the most important line, maybe in coding history. In the blog Towards Go 2, which is also linked in the Creeds of Craftsmanship link, they talk about a case where they knew that there was a problem with the way that time worked, because there's monotonic time, meaning how many seconds pass, and then there's wall clock time, which has to deal with things such as daylight savings time. So when daylight savings time hits, monotonic time continues to increment. If it's been an hour and a half, you don't say, oh, actually it's only been 30 minutes. You need to continue to count monotonic time. It has been an hour and a half now, it's been 2.5 hours. Wall clock time, wall clock goes backwards or forwards. It skips time or it goes back previously, right? They had an error with this. Or they had a potential problem. No one had the problem. I don't remember exactly what the problem was, but it had to do with a leap second. And they decided that they weren't going to handle the leap second because it only happens once every year or 2 years or something like that. So they decided they weren't going to handle it because they knew there was a possibility of error, but they didn't experience it. And Google, the Google servers do a special clock skew so that on a leap second day, the NTP server actually just adjusts the seconds off by a few milliseconds every second, so that on leap day, seconds are just off by an order of a fraction of a millisecond every second. That's how they handle the problem at Google. So they didn't deal with the problem, and then there was this big kerfuffle with Cloudflare. And then when the problem happened with Cloudflare, the way that it happened and the way that Cloudflare had to solve it and the communication that happened between the teams led them to an elegant solution so that time could keep wall clock time, monotonic time, and deal with leap seconds all in the appropriate expected way without adding too much extra cruft or having bad behavior. But they waited years to solve that potential bug. They waited until the bug actually happened and until they had enough information to solve it, and they do that a lot. You'll hear people talking about Go architecture. They'll wait 6 months to release something because once it goes in the standard library, it's gospel. They don't change they probably will never break Go syntax other than adding new things that are available in new versions. So, and you'll find this when you're having those discussions, oh, well, in 6 months we're going to add this feature. We know that this is coming down the pipeline from sales. But if you don't know, if it hasn't come down the pipeline from sales, if the other person responsible for the other microservice hasn't finished their API, don't guess. Just don't include the feature. You'll never regret it. I've regretted times when I've tried to plan ahead for something I didn't know. I've not regretted delaying. Because when something's running late, everybody's running late. I work as a contractor. People call me up. They say, hey, we need this done yesterday. We promised this last month. We need it done yesterday. Can you do it yesterday? I whip out my time machine and I go fix it yesterday. And I present it to them and I don't hear from them again for 2 months. Right? So deadlines and stuff are arbitrary. People don't need the things they think they need. You can wait and see how things go. So there should be one and preferably only one obvious way to do it. Again, this is my beef with import. There's too many ways to do. There are separate distinct. There's about a dozen, maybe more. You can look at MDN. Distinct ways to do imports and exports. Anybody that has actually memorized every way to do an import and export, I would love to know if that person exists. Right? This is senseless. Our art is not in the letters that we type. Our art is in the functionality that we produce, the capabilities we bring to the world. So there should be an obvious way to do the thing. We shouldn't have 10 ways to do things. We want to optimize for less mental load. Although that way may not be obvious at first unless you're Dutch, well, this of course means that there are team constraints. When we work on a team, we develop team values. When we work in a language, we develop language values. So although we say we want it to be obvious, obviously a person who has never picked up coding, it's not going to be obvious to them. So there are some constraints on what we mean by it must be obvious. And this is the one reference that is a specifically Python reference because the Python core team, a lot of them are Dutch. Because Guido, I think, is Dutch. Now is better than never. If we need to make a decision, we can add an API version 2. But we need the functionality now, and we know what the functionality is. So we're not stuck in that previous one of, in the face of ambiguity, refuse the temptation to guess. We know that we need it. We know what's needed. We have the requirement. So let's go ahead and implement it. Don't hold off for the perfect solution. Follow the Pareto distribution. Once you get to that 80%, move forward. If you don't know the other 20%, don't include it. You can add it later, especially with things like JSON and JavaScript, where they are dynamic in their nature. You can add new properties later. Although never is often better than right now. And anybody who has had to ship something on a given day, and the whole team is staying overnight to ship that thing. People are there until 12. Is anybody in that situation where okay? How many times has it ever worked out that it was better to ship it that night than it was to wait 2 days? Yeah. I had one case, and that was because there was a legal deadline, and it was better to ship a broken product than to not ship the product. But aside from that one case, again, never. All deadlines are arbitrary, and if something feels so urgent, and especially this applies to the rest of life, especially to dating. If something feels so urgent and so pressing that it can't wait, then something else is wrong, you know?
So the company upstairs, they would address it a number of different ways because they would still go forward. The product managers kind of led the company, and so they would still go forward with the everybody up all night, let's get this done for tomorrow because the customer needs it thing. And then we deal with for the next several months, all the issues that come from that. But I thought it was interesting that one of the ways they would address it was they had an actual rule that if you were there all night, you had to go home and sleep the next day, only because they understand that there's only so much you can do with clarity of focus in mind when you're up that late.
They don't understand how Mountain Dew works. No, I agree.
We had free food, so you could have as much as you want, and Mountain Dew was on the list, so.
Yeah. Yeah. So if the implementation is hard to explain, it's a bad idea. And this is inevitably true, because even if the implementation is correct, go back to that conversation we had earlier about marketing things, if it's difficult to explain, it's not going to catch on, it's not going to develop a culture around it, you're not going to be able to have shared understanding, and somebody else is going to implement it maybe in a much worse way. So if you have the perfect implementation, but it's hard to explain, it's a bad idea. You would be better off following the Pareto distribution, find a solution that meets the 80% and get buy-in than to deal with having a perfect solution that no one will believe you about. The other problem with perfect solutions is often you may be the only person that has enough experience to understand the value of the solution. And when you're in a room full of 10 people, it doesn't matter how senior you are, when 9 people who are junior to you don't understand the implementation, you lose that vote. So if the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, this is a seductive one, it may be a good idea. And this goes to the marketing again. There are lots of sweet things out there that sound flowery and good that are absolutely horridly bad ideas, objectively bad ideas, but they're easy to explain. So if it's easy to explain, it may be a good idea. That we should not let ourselves be fooled because it falls into the comfort of our mind's interpretation that therefore it's good. And finally, and this has already kind of come before, namespaces are one honking great idea. Let's do more of those. I do have another word on this, but namespaces meaning packages. So this comes from an era when C was much more dominant. C has no scope at all. Well, I think it has function scope. That's the only scope it has. Every package is in the global scope. So that's where this comes from, but it's very relevant still. Group things together under a name that makes sense. Now, this is my caution for the JavaScript community. We have things like Lodash. Lodash says nothing. And that is a good indicator that it's something that you shouldn't use. Utility libraries are the devil's playground. They're like the ternary operator. They're seductive, but don't use them. Very, very rarely will a utility library that has a generic name that does not communicate what it is. Now, I understand sometimes we have weird names for branding purposes. There's an authentication library called Polar, I think. It doesn't say anything, but Polar refers to this methodology of doing the authentication. Actually, I think the library is OSO. I don't know what that means, and their configuration is called Polar. Anyway, so there are cases where, for branding purposes, the names are meaningless. But when you come across something that cannot be described, and this is not, I'm going above and beyond what this is reading in the text here, but this is the inverse of that, because for every measure, there must be a countermeasure. That should be on here as well. We want to group things together. We want to put them in their own place. But if you find that it's being called stuff, lib, utils, things, config, something like that, there's a really strong indicator that you have not followed this principle. Namespaces should describe a unit of work that gets done. So if I have /lib/auth, I should probably have slash auth-in and slash auth-z to distinguish between my login logic and my permission and role logic. Auth-z being permission role logic, auth-in being login logic. Think of it like driver's license says who you are. Well, actually, that's a bad one because it does both. It also gives you permission to drive. Hall pass doesn't say who you are, says you're allowed to be in the hall. State ID doesn't say what you're allowed to do, it says who you are. That's distinction between auth and auth-z, but that's different. Anyway, the point I was trying to make is that we give things names and we put them in a namespace, and if you can't come up with a name that is descriptive, then you probably haven't followed the namespace principle. So with that, I will take comments and questions, but I won't go on to the others. We'll leave that as a part 2. Or arguments. You want to fight me? I'll take you down. If you
last one.
If you don't stand for something, you'll fall for anything. So I think it's important, as if you want to grow into the role of a software engineer, to learn from other software engineers. I don't think there's anything arguable about the Zen of Python. It is just so plain. There are other creeds that have some points that I think are a little more arguable. Perhaps some people would argue against explicit is better than implicit. But find defensible reasons for the reason you code the way you code. And remember, the art is defined by the constraint of the medium. It is not what you include, but it is what you exclude that defines your discipline. And perfection is achieved not when there's nothing left to add, but when there's nothing left to take away. So, hallelujah, amen. I'll see if there's any questions in the chat box here. Nope. Okay, well with that, I am going to go ahead and peace out and we can chat a little bit. I would appreciate your help cleaning up. And again, if you're watching on the YouTubes or whatever, Twitches, doobly-doo for the links to the cross links to the Node channel and the meetup and blah, blah, blah. Thumbs up if you got them, thumbs down if you don't, because every thumb helps. And peace.
Thanks, AJ.